This is Calculus Homework 1.1a, and in this homework what we're going to be doing is we're going to be finding derivatives by calculating slopes. This particular example is on page 2, and what we're doing is for this one we have the original function y equals sine of x, and at a bunch of different points we're going to calculate approximately what the slope of the tangent line is. At x equals -5, we're right here on the graph, and what we want to do is we want to find about what is the slope of the tangent line. You can kind of see that slope of that tangent line should be positive but low. So maybe like 0.1 or 0.3 or something like that. And the way we're going to calculate it is we need to have two nearby points, and we're going to be able to approximate the slope using those two nearby points. So what I'm going to do is I'm going to say my first point is going to be the point we actually care about. X is going to be -5. And the y value there, to get a point, we have to use a calculator. So we're going to bring this in, and what we're going to do is we're going to do sine of -5, and sine of -5 is 0.9589. Now I'm going to throughout the year round to 3 decimal places, so 0.959. But we're going to want to use exact numbers along the way of the problem. So when we do the next step, we won't be using 0.959. We'll be using the exact number that the calculator got us. But to save some writing, we don't need to write them all down. A nearby point to x is -5, I could go in either direction. I could say x is -5.001, or maybe x is -4.99. It doesn't matter which one you use. You'll get the right answer either way. So I'm going to start with x is -4.99. That's just to the right of -5. And I'm going to find what the y value is at that point. And I'm going to do this using a calculator again. Sine of -4.99 is 0.9617. Again, I'm going to write down the y value is 0.962, but I'm going to use the exact numbers, otherwise we're going to get pretty bad answers. Once we have these 2 points, we're going to use the slope formula. The slope formula is y2 minus y1 over x2 minus x1. It finds the slope of a linear function through 2 points. So I'm going to take the exact number for y2, and I'm going to do it by highlighting it in my calculator and pressing enter, minus the exact number for sine of -5, and divide by -4.99 minus -5. And when I do that, the answer I get is 0.2788. What this represents is the slope between these 2 points, which is approximately the slope of the tangent line. So the slope of that tangent line is 0.279, and I'm fine to write that to 3 decimal places. So this line had a very low slope. It was almost 0.3, and we're going to do the same thing for other points. When x is -3, we want to find the y value and find another nearby point. I did this on another sheet of paper, so you don't have to watch me plug things into calculators. When x is -3, y is -0.141. When x is -3.001, the y value is -0.14. And again, I'm going to do y2 minus y1 divided by x2 minus x1, and that will find the slope between these 2 nearby points. And those slopes came out to be -0.99, -0.416, 1, -0.421, -0.989, and 0.288. Now, these were the numbers I got using my numbers. Your numbers very well may be slightly different. In fact, unless you randomly choose the exact same numbers mine are, you should have slightly different numbers than this, but they should be very close to this. Notice I put exactly 1 here. My answer was like 0.99999, and so it rounded to 1. You don't have to put 1.000. If there are zeros, it's fine to write down 1, because 1 and 1.000 mean the same thing. So once you have the approximate slopes at all these different places on the graph, we're seeing what are the slopes at these different places. What we're going to do is we're going to graph what these slopes are to see if we can come up with what the derivative function is. So when x is -5, the slope of this line was 0.3 about. When x was negative 3, the slope of this line was about negative 1. When x was negative 2, the slope was about negative 0.4. When x was 0, the slope was 1. When x was 2, the slope was negative 0.421, so negative 0.4. When x was 3, it was almost negative 1. And when x was 5, the value was 0.288. So the question is, what's going on here? And I think sometimes it helps just to connect the points and see if we can see a pattern. If I'm connecting these, I'm going to get something like this. And your job, having come from pre-calculus, is that this should ring a bell for you. This should be like, oh, that kind of looks like a function I know. And in this case, we got the point 0,1. It's making a wave-like thing that seems to repeat. It is even. It's got the same values on both sides of the y-axis. And so my guess would be that this is a cosine graph, which would look something like this, and if you wanted to, you could check more points later on and see, does it match up with cosine? Or you could say, like, hey, what was cosine of 2? Cosine of 2 was negative 0.416, which is awfully close to negative 0.421. So that seems to validate that this might be y prime, the derivative of the original function, equals cosine of x. I hope that helps. If you have more questions, feel free to ask before or after school.